Okay, let's solve some radical equations. So we look at number 1. Basically I have negative x plus the square root of 6x plus 19 is equal to 2. So one of the things you want to remember about radical equations is to isolate the radical. So we want to get the radical by itself before we square both sides. A very common mistake would be to just square everything and say, oh, this is x squared plus 6x plus 19 equals 4. But this is not true, because if you have like 3 plus 2 equals 5, which is definitely true, and then you just square everything, is 9 plus 4 equal to 25? No, it is definitely not equal to that. So you can't just square across addition. No squaring across addition, no exponents across addition. That doesn't make any sense. So square root of 6x plus 19 is equal to 2 plus x. Now we can square both sides to get rid of the radical. So we get 6x plus 19 is equal to 2 plus x all squared. It's not 2 squared plus x squared. Again, you cannot square across addition. But you can square this in parentheses. That gives you 6x plus 19 is equal to 4 plus 4x plus x squared, because I'm doing 2 plus x times 2 plus x. And that's giving me 4 plus 4x plus x squared. Now I'm going to set it equal to 0 because it's a quadratic equation. So x squared minus 2x minus 15 equals 0. So I moved things around, but basically I moved these over here and then switched sides, so it looks like that. Then I can factor. This would be x minus 5 times x plus 3, because negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. So x can be either 5 or x can be negative 3. So now I need to check my answers to make sure that they work. So if I plug in negative 3, I'm going to get 3. And then the square root of negative 18 plus 19, which is 1. And that would have to equal 2. Well, that says 3 plus 1 equals 2, which it doesn't. So this is an extraneous solution. 5, I would get negative 5 plus the square root of 30 plus 19, which is 49, is equal to 2. So negative 5 plus 7 equals 2. 2 equals 2. That is correct. So my solution is x equals 5. Okay, and that makes sense. A square root should only cross a linear function once, right? I don't know exactly what 6x plus 19 looks like, but I do know what 2 plus x looks like. 2 plus x, x plus 2 or 2 plus x looks like that. 1, 2, 3, 4, 5. So here's 5. And the square root of 6x plus 19 well, it's equal to 0 at something close to negative 3. So 1, 2, 3. It starts, right about in here. And then if you plug in 0, you get square root 19. So that's like 4 point something. So it's going to come up like this. And anyways, they're going to cross once at 5. So that's that equation. Moving on to equation B, a little simpler. We have negative 10 square root x minus 10 is equal to negative 60. Divide both sides by negative 10, you get square root x minus 10 is equal to 6, right? Because you're dividing. Square both sides, you get x minus 10 is equal to 36. So x equals 46. If we plug that back in there, 46 minus 10 is 36. Square root of 36 is 6. 6 times negative 10 is negative 60. So this answer works. We expect the square root of x minus 10 to equal 6 once, right? 6 is right 1, 2, 3, 4, 5, 6. Y value 6. And square root x minus 10 has been moved over to the right 10. So it's going to come up like this. And it's not going to hit 6 until 46. So it takes a while to hit it, but it does intersect once. Okay, moving on to letter C. We've got a fourth root now. Fourth root of 7x plus 2 is plus 15 is equal to 17. So again, isolate the radical. Fourth root of 7x plus 2 is equal to 2. Raise both sides to the fourth power, so 7x plus 2 equals 2 to the fourth power. 7x plus 2 equals 2 to the fourth is 2 times 2 times 2 times 2, which is 16. So 7x needs to equal 14, so x equals 2. Checking our answer, 7 times 2 is 14, plus 2 is 16. The fourth root of that is 2, plus 15 is 17. So this is the solution that we expect. Even roots have 1 or no solution, so this even root has 1. Finally, I threw in a quadratic just for kicks and giggles. So 2 times x minus 3 squared equals 16. Again, you can isolate the power and then take a square root. So x minus 3 squared in a square root is equal to the square root of 8. When you take a square root of something squared, you get absolute value, x minus 3. So that's equal to the square root of 8. So x minus 3 equals positive root 8, or x minus 3 equals negative root 8. So x equals 3 plus root 8, and x equals 3 minus root 8. Now, root 8 is root 4 times root 2, so we could write it as x equals 3 plus 2 root 2, and x equals 3 minus 2 root 2. Okay, and both of those are going to work if we plug them back in, because a quadratic should cross the line 8 twice, right? X minus 3 squared equals 8, so x minus 3 is here, and it should cross the line 8 2 times right there. So that makes some good sense. Okay, moving on to question 2. It asks, how many real solutions do you expect from the following equations? Square root x equals negative 2. That's the square root of x. This is negative 2, so no solutions. Cubed root x equals negative 2. Well, cubed roots always have one solution, but cubed root looks like this, and negative 2 is here, so they cross once. So one solution. X to the fourth equals negative 2. X to the fourth looks something like this. Negative 2 looks like this, so no real solutions. Finally, x to the 1/4 equals 2. X to the 1/4 looks something like this. It's an even root. 2 is here, so there should be one solution. And I guess there's one more, which is a little bit of a stretch problem, but x to the 2/5 equals 2. So x to the 1/5 looks like this. This is x to the 1/5. But when you square it, all your negative values become positive. So it looks like that. And how many times does it cross 2? It actually crosses twice. Because this is sort of like a quadratic. When you square it, it's almost like a quadratic. So there should actually be 2 solutions to that. Final thing I put in here with radical equations was rationalizing the denominator. So remember that if you have 5 over the square root 2, you can multiply by root 2 over root 2, which is just 1, to get 5 root 2 over 2, and now we don't have a radical in the denominator. If we have something like 1 over 1 minus 4 root 3, you can multiply by the conjugate, 1 plus 4 root 3, 1 plus 4 root 3. So what happens there is when you multiply conjugates, you just get the first one squared minus the second one squared. So the numerator will be 1 plus 4 root 3, and the denominator will be 1 plus 4 root 3 minus 4 root 3, so the middle terms cancel, plus, or no, not plus, minus 16 times 3, because that would be 4 times 4 and root 3 times root 3. So that is 1 plus 4 root 3, all divided by 1 minus 48. 16 times 3 is 48. So that is 1 plus 4 root 3 divided by negative 47. So that takes care of radical equations and rationalizing the denominator.